Welcome to CIS 9467 midterm assignment. My name is Carlos Scuderi and I will be presenting the management dashboard for visualizing and analyzing restaurant food inspection results. So the food industry represents a sizable market for the New York City. With about 40,000 restaurants, the New York City Department of Health and Mental Hygiene performs a yearly unannounced audit to test for food quality. The results are made available in the New York City Open Database on a daily basis. With about 370,000 rows and 15 columns, that results with a total of 5.5 million fields of structured data. The type of report being created includes information such as the name of the restaurant, the location both at street level as well as borough, the type of food being served at that location, and then includes information about the type of violation that has taken place and resulting number called offense score. The data again can be located in this link, which will be provided later. Now, the type of question that we would like to answer with our analysis, and the intent here is to how we can actually help the Department of Health and Mental Hygiene to work with its limited resources to best improve food quality. So we'll be looking at the previously presented variables, such as the type of restaurant, the restaurant itself, the type of food being served, and the overall geographical concentration to see how these different variables played out with the resulting offense score. Here's the finished dashboard, and we'll be going in more detail later, but it does contain an area where the different charts are being presented, and then on the right side we have the different Excel slicers, which will help us filter the different graphs so we can look at certain data in more detail. And then finally we have a section for the violation code, because actually the information for violation code, it only contains the specific code numbers. So over here I have added the reference for the user to have a quicker way to identify the subject being discussed. Moving to the raw data. So here's the report that is downloaded from the New York City database. And over here we can also see that we have the 375,000 rows. Here we have also the different columns with the data fields, and over here we have the offense score that we will be addressing later. But before we move on, I would like to make the point that working with 370,000 rows has been proven complicated both in CPU processing time, so it has been very difficult to work with this amount of data, and also has been creating some issues with the slicers. So what I have done is I have taken a data subset that produces comparable results, yet it just addresses the shortcomings. So here is the data subset where already we can see far less columns, and we'll have about 5,000 rows. We have here the offense score. So the offense score is a continuous variable that starts from 0 all the way to over 28. And depending on the type and amount of violations, restaurants can have a higher number the more amount of violations they have. And so this value also correlates to the grading scales typically seen on the labels before somebody enters a restaurant. So any value equal or less than 13 results in an A grade. 14 to 27 will result on a B, and C will be anything equal or higher than 28. So we have used over here conditional formatting just to help the user to more quickly identify the restaurants and potentially in which of the three buckets may fall in. This type of conditional formatting has been used throughout the analysis just to help, again, the reader or the user to always keep track of the different events. Moving to the pivot, the food pivot, we have created over here a pivot table and a pivot chart. It contains actually two different calculations, the sum of the offense score as well as the average. Now we are tracking two different variables due to the fact that due to a cumulative effect, it might be that, for example, American food is far more common than Caribbean, so obviously we may have a far bigger number when it comes to offense scores. However, if you look at the center of the distribution over here, one can already see that Caribbean may have a higher average offense score value than we would have in American food. So again, sometimes you need to look at the two variables just to come to a final conclusion. Violation code has been created following a similar approach. We have here a pivot table and then the different offense scores over here, which has resulted in a bar chart where we are basically measuring all the different categories. We'll talk a little bit about the different codes later in the dashboard. Restaurant pivot has been created again using a pivot table and a pivot chart. Here we have only taken the top 10, so this data has been filtered. It has again the total score and average score, and we have used a combo chart that mixes or combines both a bar chart as well as a line chart. The line chart represents the average score, whereas the column chart represents the total score, again just to keep track of the two different variables. When it comes to borough, although we have used a similar pivot table with the 5 different boroughs, I have decided just to use a pie chart in this particular case because it's sometimes easier for the reader to track pie charts. And I think it's natural to have a pie chart with a borough so somebody can quickly identify the different pieces of the pie and then select a filter and go deeper analysis. This results in the final dashboard. So the final dashboard again has the graphs on the left side, and on the right side we have the different slicers. Starting with the borough on the top right, top left corner, and then moving to the type of violation on the top right, and then at the bottom side we have the offense score by restaurants and also the offense scores by food type. Now this type of analysis can be performed in multiple different ways. So let's say, for example, that in the Department of Health and Mental Hygiene we would like to work with our Manhattan inspectors. So first we'll come in and we'll click on Manhattan, and then we'll be looking at, okay, which type of restaurants we would like to send these people in. So over here we can very quickly see that Starbucks, then followed by McDonald's, are the top 2, and together, for example, with Domino's, or top 3 restaurants that we should send our inspectors to. Then over here we can very quickly see that the top violation is related to the improper construction of structures that are in contact with food, and that might lead to an impaired ability to have that area clean so the food can get contaminated. So we can also perform a similar analysis. Let's say, for example, we want to address a specific restaurant. So we were talking about Starbucks. So over here we'll click on Starbucks, and now we'll see that, for example, most of the Starbucks stores that have most of the compliance issues are located in Manhattan. So it's kind of consistent again that we may send our Manhattan inspectors first, but also this can help us prepare talking points or agenda with the people from Starbucks. So we can bring that discussion to say, your main issues that you have is again related to the 10F non-compliance code, and then we can work with them to define an improvement plan and define a timeline by when they need to be ready. Finally, we can do a similar analysis with food. So whether American food has been the main challenge, we can select it here, and then we can work with other restaurants to make or trying to improve the overall food. So again, in summary, we have prepared this Excel dashboard to help the New York City Health and Mental Hygiene Department to better focus its resources and improve the overall food quality. We hope that you have enjoyed the presentation. Thank you very much.